Hello everyone. Now I am going to explain about our project, which is diabetic foot ulcer identification using machine learning. The main abstract about our project is diabetic foot ulcer is the main complexity of diabetes nowadays. It might lead to cut of the foot. The treatment approach has drawbacks such as the high cost of diagnosis as well as the time complexity of the treatment. The analyzers had proposed many methods based on the technology, which depends on both hardware as well as software also. And now we are going to propose a work. We have used an image dataset of around 1500 images. We trained the model with advanced convolutional neural networks of 11 layers with almost 70 approaches and with the best possible accuracy. Introduction. A diabetic foot ulcer is an open sore area wound that occurs approximately 15% of the patients with diabetes and is commonly located at the bottom of the foot. Of those who develop a foot ulcer, 6% will be hospitalized due to infection or other ulcer-related complications. Diabetic foot ulcer should be known in prior to prevent from adverse effects, so the foot with ulcer should always be monitored manually or by any device. We do have some traditional methods like diabetic foot ulcer screening instruments, 3D thermal camera assessment systems, which takes more time to cure. Nowadays, diabetic foot ulcer detection came up with some advanced software detection technologies which can determine whether it is a normal skin or abnormal skin. A good deal of deep learning and machine learning methods and algorithms are implemented on diabetic foot ulcer image dataset to know the wounded area with better accuracy of output. Deep CNN and faster RCNN models with the cooperative analysis of different algorithms like GoogleNet, LXNet, etc. are analyzed. Decision fusion and DFUNet is implemented on the normal and abnormal ulcers. The hardware equipment with a pressure sensor is created for diabetic foot ulcer detection. And as proposed work, we have decided to increase the accuracy of the model. The accuracy is increased by having a larger data set. The model is trained with an advanced convolutional neural networks of 11 layers of almost 70 approaches, and the web application is implemented for early easy access of information. And the problem statements are manual inspection of proteast remains the ideal solution for the diagnosis of DFU. Human observers achieved low validity and reliability for remote assessment of DFU. Therefore, computerized methods could be used as a tool to improve human performance. So, our project aims to analyze the wound and make a computerized methods to get improved results for future. And this is our proposed work. Here the inputs are given in the form of images and they are classified as 3D patches, and in the convolution layer we have so many layers. In the 2D convolution layer and max pooling layer, most of them are used, and they are fully connected, FC1, FT1, and they are like this. First, we have to import the libraries, load the data set, pre-process the data, designing a machine learning model, and predict the results. These are the proposed model, and in the following slides I will be telling about how the process is done. In the proposed method, the data set taken was a image collection from medical organization, and some of the images are taken from the reputed website called Kaggle, which is one of the best platform for machine learning researchers. We also have collected few images from the patients manually also. The dataset contains images of around 1500 in the size of 224 into 224. The whole dataset is divided in the 4 different folders, that is original image, patches of the original and abnormal skin, test set and training set. In the CNN, when it comes to machine learning, artificial neural network performs really well. Artificial neural networks are used in various classification tasks like image, audio and words. Different types of neural networks are used for different purposes. For example, for predicting the sequence of words, we use recurrent neural networks, that is RNN, and more viciously LSTM. Similarly, for image classification, use convolutional neural networks. A convolutional neural network can consist of more or one multiple convolutional layers. The number of convolutional layers depends on the amount and the complexity of the data. We have many CNN algorithms and models in which we have chosen an algorithm of 11-layered architecture of CNN from many models. The 11-layered architecture is compared with the ResNet model, in which we have achieved more accuracy than the compared model. The web application for easy access of results and faster treatment for the patients. And now we will be seeing about the implementation steps. First, creating an appropriate data set of around 1500 images by collecting the images from reputed hospitals and importing the libraries such as NumPy, TensorFlow, Keras API, OpenCV, etc., which are usual and suitable for software and the deep learning models. Loading the dataset, which is saved in PC, and uploading it in the model to train it. Pre-processing the data with some image processing and data augmentation techniques to increase the modify the dataset to get a larger dataset so that the accuracy can be increased. Now the dataset is ready. We need to design a machine learning or a deep learning model based on the requirement and the training model with the dataset which we have created. Now we need to predict the model and check the parameters like accuracy, loss, etc., and have a comparative analysis of the proposed model with that of the other CNN models. In the following steps, the image is taken as an input and represented as a grid. The image grid is basically a matrix. Now the matrix is divided into many parts like vertical line filter and looping filter. Here we can see the pooling, convolution and pooling sector also here. And the image grid is multiplied with each of the filter. The result become a feature map. The feature map are basically feature detectors. The feature maps are formed in feature extraction process and classification is done. The combination of feature extraction and classification models forms a convolution layer. And as I said earlier, and we can see that the matrix is divided in a 4x4 matrix is divided into 2x2 matrix. The 4x4 matrix is taken and is reduced to 2x2 matrix by taking the largest number in each of the subsets. This is the process. And when we come to the results for the proposed for our proposed model, the accuracy is nearly 100%, and we can say it is 95 to 97%. When we comes to the loss, it is less than 0.1%, as we have get our results very accurately. And for the comparative model accuracy, the 7-layered comparative algorithm is inadequate for given dataset with less accuracy, and also the loss of comparative model is more than the proposed model. As earlier I said, we have developed a web application. When we have trained our model such that we can detect whether the given image is ulcer or not. By uploading the images, we can say that here we can see that the wounded one is an ulcer and the non-wounded one is an ulcer, and this is the web application which we have taken. By giving the logins, we can upload. By giving the logins, we can log in and then we can upload the images when we can detect the foot is normal or abnormal. Conclusion: we proposed a model for diabetic foot ulcer identification with more accuracy and almost probability. The result can be accessible by web application. It can be effortless way for most of the diabetic patients. The treatment done for diabetic foot ulcer patients become faster without much delay. Though there are many models for diabetic foot ulcer detection, the proposed model can be appropriate way for the given dataset. And these are some of the references we have taken from the IEEE model, IEEE conferences. And thank you very much for listening us. Thank you.